Hi dear students, this presentation is from the third module of the subject Advanced Energy Engineering. In this presentation, last presentation we have already discussed about the wind energy, and now we will move on to the working principle of the wind energy conversion. So first we will discuss principles of wind energy conversion. There are two primary physical principles by which energy can be extracted from the wind. Okay, these are through the creation of either lift or drag force. So by either by creating the lift force or by creating the drag force, we will be extracting the energy from the wind. Okay, sometimes combination of these two is also being used. Okay, in general, the working of the windmill is based on either lift or drag principle. Okay, from the figure shown below, you can see this that blue colored shape. This one is the, we will call it as airfoil shape, or the specially designed shape for the blades of the wind turbine. So in this case, what happens is, you can see the lower part, the fluid is flowing over the aerofoil shape or the over the object. Then what happens is, see, you can see here the lower part, the particle has to traverse a lesser distance. The distance from this point to this point is very less at the lower part, whereas at the higher part you can see always there will be a higher path for the fluid to cover. So the fluid passing above the surface will have to cover more distance than the fluid which is passing through the lower part. So finally this will be merging together at the bottom point or tail end. All the fluid will be joining together. We know that discharge to be remain constant. That means here whatever discharge is there, that discharge is to be maintained here also. So what happens is, the fluid particle flowing above the surface will have to cover more distance. That means it has to travel in a much higher velocity than the particle flowing through the lower part. So here the distance is less. That means this particle to travel in a lesser velocity than the particle which is flowing over the object. Since the distance to cover is more, the velocity also should be higher. So only option is, see, we know if one form of energy is increased, means here kinetic energy is increased in the upper portion velocity has to be increased due to the flow contour or the higher distance to be covered. So that means velocity to be increased means kinetic energy is increasing. So only option is to reduce some other form of energy, that is pressure energy. So at the upper part of the aerofoil shape, we will experience a low pressure, whereas at the lower part, since the velocity is less, means the pressure will be more compared to the upper part. So the pressure difference is created from lower part to the upper part. Here the upper part we will have the low pressure, whereas at the lower part we will have the high pressure. So this difference in pressure is causing for some force, that is what is known as the lift force. So lift force which is acting on the airfoil shape will be always perpendicular to the flow direction of the fluid. See, the direction of the flow of the fluid is from left right, and the lift force is from down to upward. So always the airfoil or the blades will be rotating in this direction. That is what is known as lift force. So this is the basic aerodynamic principle of operation of the wind turbines. Okay, so I think the concept is clear for you. Now drag is just the resistance to the flow of an air, and drag force will be always acting along the direction of the flow. See, if an object is placed within a flow, due to the flow velocity of the medium, the object is experiencing some resistive force. That force is known as the drag force. Resistance for the flow in the direction of the flow is known as drag force. So every object is experiencing drag force always, but lift force is created only by producing the airfoil shape or necessary pressure difference at the lower part as well as the upper part. By creating that pressure difference only, we can create the lift force. But the lift force is much dominant than the drag force. Always a creation of the lift force will lead to the, sometimes along, not sometimes, always along with the lift force there will be a drag force also. Lift is created by the flow of air over an aerofoil. The shape of an aerofoil causes air to flow faster on the top than on bottom. See, that that velocity difference at the top and bottom layer is created by the shape of an aerofoil. The fast flowing air decreases the surrounding air pressure. See, since the fluid at the upper part has to travel more with a more velocity, of course the pressure will be less. So with the expense of the pressure, kinetic energy is increased there. Because the air pressure is greater below the airfoil than the above, the resulting lift force is created. So due to that pressure difference, a force is created, that is what is known as the lift force. Lift is perpendicular to the direction of the airflow. Now coming to the drag, every physical body that is propelled through the air will experience a resistance to airflow. This resistance is called the drag. Drag is always in the direction of the airflow. So two forces are there in a flow field. One is drag force, that is drag is always acting along the direction of the flow, and lift is always perpendicular to the direction of the flow. Generation of the lift always causes a certain amount of the drag to be developed. With a good airfoil, the lift produced can be more than 30 times greater than the drag. That is very important. See, the lift force produced with the very good designed airfoil, lift force produced can be more than 30 times of that of the drag. So of course the energy that we can harvest by using lift energy technology will be much higher than that we can expect by the drag. Lift devices are generally more efficient than the drag devices. So since the energy available is more, lift devices are more efficient than the drag devices. നിങ്ങൾ കണ്ടിട്ടുണ്ടാകും ലിഫ്റ്റ് വെച്ചിട്ടുള്ള വിൻഡ് ടർബൈൻസ് നിങ്ങൾ ഓൾറെഡി, അല്ലെങ്കിൽ വിൻഡ് മിൽ. What is the difference between wind turbine and windmill? Both are not the same terms. Actually, wind turbine is creating the electricity from the wind energy. That is what is known as the wind turbine. If the windmill is producing electricity, then it is commonly known as wind turbine. Wind turbine means just extracting the mechanical energy, extracting the kinetic energy from the wind and it converting it to mechanical energy. That's all is. Its purpose is just to convert it into wind energy into mechanical energy. That is what is known as windmill. And the final output can be used for some other purposes. If it is connected to generator, then we will call it as wind turbine, since we are producing the electricity. If it is not connected to the generator and we are using it for some other purposes, like for the pumping of the water, we will be using the wind energy, and for some rotation purposes, generating some rotation purposes, we will be using the wind energy. For small lot of other applications are there with the wind energy. So if the wind energy converted into mechanical energy is used for some other purpose other than the electricity production, then we will call that structure as windmill. Otherwise we will call it as wind turbine. So structure and everything will be same. If the electricity is produced, then only we will call it as wind turbine. Otherwise generally we will call it as windmill. Don't confuse the term wind turbine with the windmill. Both are not the same. Depending on the end product, we will call it as wind turbine or windmill. Okay. So lift is generally more efficient than the drag. അപ്പോൾ നമ്മൾ ഞാൻ പറഞ്ഞു വന്നത്, what I have told you is, you might have seen the wind turbines working on the wind. I cannot say wind turbine, it is actually windmill only we can say. Anyway, the model of a turbine working on the wind principle is exhibited in front of our college as well as in front of the lab. You might have seen all these are working based on the drag principle only. See, it is just utilizing the velocity of the energy to produce the rotation. That's all. There is no aerofoil shapes and nothing is there. Just what we are doing is we will be providing a resistance to the flow of the fluid. Due to that resistance, the fluid will exert some force on the body which is placed in the flow. So that is being thrown back. That is what is happening. So it is, since it is connected to a rotor, the continuous rotation is produced. So that is the basic working of the wind turbine or windmill based on the drag principle. Anyway, we will be discussing it in detail. All the wind turbines work on either drag principle or lift principle. Drag principle. Coming to the drag principle, drag devices are simple wind machines. See, these are very simple wind machines. There is no complicated airfoil shapes and all. Drag devices are simple wind machines that uses flat, curved or cup-shaped blades to run the rotor. See, the blades of the wind turbine working on the drag principles are either flat-shaped, curved or cup-shaped. Okay, so there is no aerofoil shape. That is important, unlike aerodynamic shapes of the lift devices. So this is what I have told. The wind turbines or that model of the wind turbine placed in front of our college and in front of the lab are of this based on the drag principle only. In the drag blade design, the wind pushes the blade out of the way. See, if the wind is blowing, an object is placed as an obstruction to the wind flow, then what happens is wind will be exerting the force on that obstruction. So here the obstruction is the blades of the wind turbine. In the drag blade design, the wind pushes, so the wind will always push that blades out of the way. It will try to push that blade out of the way. That is what is happening. That is how the rotation is created. So next blade will be coming in contact with the air. So that is again is being pushed back. So continuous pushing of the blades continuously coming in contact with the air will create the rotary motion, since all these blades are connected to a rotor. So drag powered wind turbines are characterized by slower rotational speeds and high torque capabilities. Now coming to the lift principle, the lift devices employs the same principle that enables airplanes, kites and birds to fly. See, the lift principle is actually utilized by the movement of the airplanes, kites means patam, okay, the birds to fly. Everything is using the same lift principle to fly. The blade is essentially of airfoil or wing. We will generally call it as wing. The top surface of the blade airfoil is more curved than the bottom surface. When the air flows past the blade, a wind speed and pressure difference is created between the upper and lower blade surfaces. This will create the lift force. We have already discussed this principle. So there is actually, in this case, the wind is not pushing the blade away from the flow direction. Actually, the wind will be always aligned with the direction of the wind. Okay, so see, a plate is kept parallel to the flow direction. That is what is the meaning of the, in that case, like that only the blades are situated. So always the blades surface will be parallel to the flow direction of the wind. So what happens is some streamlines of the flow or of the air or the wind will be flowing through the upper part of the blade. Some flow will be through the lower part. See, I have already told the upper part is made of longer distance compared to the lower part. Due to that, the pressure difference is created, and due to that pressure difference, lift force is created always perpendicular to the flow direction. So that perpendicular force acting to the flow direction is pushing the blade from lower side to the upper side. So that is what is happening here. See, in the case of drag principle, the blade will be moving along the direction of the wind flow, whereas in the wind turbine working on the lift principle, the blade will be always moving perpendicular to the flow direction of the wind. Okay, so purposefully we are creating some lift force, and it is utilized for the harvesting the wind energy. That is what is the wind turbine based on the lift principle. Now coming to the working of the wind turbine, this is actually shown here is a wind turbine work based on the lift principle. These are the basic components of the wind turbine. You can see the blades are attached to the hub. See, this is the hub, and the blades will be attached to the hub. These blades will be of aerodynamic shape. Usually minimum 2 to 3 blades will be there. That is the maximum. To get the maximum energy, we will be going for 2 to 3 blades. So this entire part is commonly hub plus the rotors or blades are commonly known as the rotor. This arrangement together is known as the rotor. Now this part will be harvesting the wind energy and converting it into rotational force. So the wind energy is harvested at the blades and hub. So the blades will be continuously rotating. So that rotation is given to the shaft. This is slow running shaft, slow speed shaft. Now we know that the velocity of the wind is very small. So of course the rotation of the blades or the rotary rotation of the blades per second will be very less. We have to enhance that RPM to a very high value. For that we will be using some transmission systems including gears and all. So actually this is the transmission system. The rotation from the rotor is given to the transmission system. Inside the transmission system we will have the gear arrangements to increase the rotary speed or to fix the rotary speed, and once the speed is increased, that is given to the electrical generator. With the required speed, now the RPM is given to the electric generator to produce the electricity. So transmission system will have the speed increaser, drive shaft and clutch, braking system, coupling, etc. So why we go for the braking system is clutch and braking system we will be using is sometimes the wind velocity cannot be uniform. Sometimes it can have a non-uniform flow or very high wind velocity will be there. In that case, there can be possibilities of accidents. So in uneven operation RPMs, if the rotor speed becomes very high, at that time we will not generate the electricity, and at that time we have to stop the working. For that we will be using that braking system. Okay, so the next important part is the frame supporting structure of the tower. This is actually of shown as a simple figure, but in reality it is of very huge. It is actually of very huge in size. Even meters of length will be there. 30 to 100 meters of length will be there, and the structures are made of either steel, mostly of steel or concrete, and it's a massive structure. Even erection of this wind turbine itself is a tedious task. It is not very simple to establish the wind tunnel. So the initial cost always will be very high, of course. Now coming to the components of the wind turbine, first one is nacelle. Nacelle is the cover housing that houses all of the generating components in a wind turbine, including the generator, gearbox, drivetrain, and brake assembly. So all these are included within this covering. This uppermost covering, which includes gearbox, generators, and driving system, everything is known as the nacelle. So this outer overlap is known as the nacelle, or housing. We'll simply call it as a housing for gearbox, everything extra. Okay, nacelle is the cover housing that houses all of the generating components in the wind turbine, including the generator, gearbox, drivetrain, and brake assembly, etc. Now coming to the rotor that I have already explained, blades and hub together is called the rotor, and is attached to the slow speed shaft. This is slow speed shaft, and this one is high speed shaft. See this, the slow rotation of the hub and blades are converted to high speed rotation using the gear transmission. Okay, so appropriate gears will be connected, meshed together, so that the speed can be increased, RPM can be increased, that you might have studied in the mechanics of machinery. Okay, rotor blades hub together is called the rotor, is attached to the slow speed shaft. Now blades are manufactured from fiberglass reinforced polyester, simply known as FRP, either from FRP or steel or aluminum. Sometimes wood polished blades are also there. FRP is lighter and exerts less stress on the bearing and rotor hub. So usually the FRP is most commonly used because it is lighter in weight and exerts less stress on bearing and rotor hub. So if the accidents happens, it will create a lot of problems. So we must be very careful about the safety of the wind turbine. So less stress should be there on the bearings, rotor hub, etc. So that is actually satisfied by using FRP as the rotor blades. Now coming to the next component, that is hub and shaft. The blades are attached to the hub. Hub is the front portion of the shaft which faces the wind direction. It is always not that it is not mandatory that the hub to face the wind direction always. Based on the whether it is facing the wind direction, it is called as upmill and downmill. We will discuss in later. Anyway, the hub is the portion of the end portion of the shaft, slow speed shaft, where the blades are connected. Usually the hub shape will be of conical in shape, and other end of the shaft is connected to the transmission. So one end of the hub will be conical in shape, where in that portion we will be connecting the blades, and the other end of the hub, that is the remaining shaft of the hub, is connected to the transmission system. So that is hub and shaft. This is hub and shaft. This is hub, and this black colored line this is shaft. So this is the integral part. The one end of the shaft is made a special shape, that is what is known as hub. Now coming to the next component, that is anemometer. So actually we have to measure the wind velocity always, and we have to do the adjustment correspondingly to produce the continuous energy from the generator. To continuous electricity production from the generator, we have to supply the continuous rotation to the generator, or uniform speed is to be provided into the generator. So we must be very careful about the wind velocity and all. So for that, to measure the wind velocity, we will be having an anemometer. Measures the wind speed and is fed to the control so at pitch angle the and yaw is controlled. Always the anemometer is not shown here. Anemometer will be placed over the nacelle. So you might have seen some rotating cup shaped something will be rotating continuously over the structures and all. That is what is known as anemometer. So that will measure the wind speed. So and that once the wind speed is measured, that signal is passed or that information is passed to the control system, electronic control system, which is along with the transmission system. So that will control the speed of the gears and all. So along with that, we know that always the wind turbine has to face the wind direction. So always it has to be faced towards the wind direction. So that is also, so continuously the entire nacelle is to be rotated. ചില സമയത്ത് ഇപ്പം കിഴക്കുന്ന് പടിഞ്ഞാറോട്ടാണ് വിൻഡെങ്കിൽ എന്ത് ചെയ്യണം, നാസിലെ കിഴക്കോട്ടേക്ക് വിൻഡിൻ്റെ ഡയറക്ഷനിലേക്ക് എപ്പോഴും തിരിച്ചു വെക്കേണ്ടി വരും. So that is manually it is not possible. For that tracking purpose we will be using yaw system that we will discuss in detail. That was the last university question. So anyway, the mechanism of yaw is also controlled by the controlled from the data available from the anemometer. Control so pitch angle and yaw is controlled. Based on that information, we will be controlling the pitch angle as well as the yaw mechanism. Now coming to the next component, that is transmission system. Transmission system transmits mechanical power generated by the rotor to generator. It contains gearbox, clutch, braking system, everything. Okay, it must be designed for high dynamic torque load due to fluctuating power output from the rotor. That is very important. Always the wind speed will be fluctuating, so as the power output from the rotor will be fluctuating. So we have to experience that very much fluctuating load. So the gear, this one transmission system should be designed for high dynamic torque load. Okay, so now coming to the next component, that is electric generator. So that you will be knowing, most of the grid connected wind turbines uses asynchronous or induction generators. Grid connected means electricity producer direct line like connect ചെയ്യാതെ നമ്മൾ സപ്ലൈ ലൈനിലേക്ക് കണക്ട് ചെയ്യുന്നത് ഗ്രിഡ് കണക്റ്റഡ് എന്ന് പറയുന്നത്. Most of the grid connected wind turbines uses induction generators, but these induction generators are having disadvantage that it will draw reactive power from the grid system. So this may absorb the power from the grid system. Call it as reactive power. I am not that much familiar with these terms and all. So if you are having any confusion, you can contact your electrical staff. Now synchronous generators do not require this reactive power, hence are used by the utilities. So if you are not providing the power to the grid system, then we will be using synchronous generators. So the reason is they do not require the reactive power. That is the only reason. So now coming to the last component and important, that is yaw control system, used to continuously orient the rotor to the wind direction. See, always the rotor is to be facing the rotor to face the wind direction. So that is being done by the rotation of the nozzle, and this rotation of the nozzle is controlled by that mechanism which will control the rotation of the nozzle or the alignment of nozzle always towards the direction of the wind is what is known as yaw control system. Its working is based on the data fed from the anemometer that I have already told. So it is done by using a rotary actuator attached to the gear ring at the top of the wind tower. That is what is this instrument is called. It is done by using a rotary actuator. So there will be a rotary actuator, that a device which will make the instrument to rotate. That is what is known as rotary actuator attached to the gear ring at the top of the wind tower. A slow closed loop control system is used to control the yaw drives. See, based on the some electronic data input, it will be operating. A slow closed loop control system is used to control the yaw drives. So the function of the yaw control system is to align the rotor always to the wind direction. So direction of wind may change from time to time. So with that change in direction of the wind, we have to align the direction of the nacelle also. So that is being done by the yaw control system. Okay. Now coming to the next component, that is storage and energy converters. Most common, usually the electricity produced has to be stored. The most common storage system is the lead acid battery. So this is one of the major headache. So there is not much development in the storage case. If we can improve in the case of the energy storage or electric energy storage system, we have some other options are there, then we can harvest lot of energy. One of the major limitation is with the, still we are using the lead acid battery. Usually the electricity produced is DC, so energy converters will convert it to AC before supply to the grid or household appliance. That we have seen in the case of the solar also. So usually the energy produced will be DC type direct current. So before giving it to the household appliances or to the grid, we have to convert it into AC. That is being done by the energy converters or alternators. Now last important component is the tower. The tower of the wind turbine carries the nacelle and the rotor or structure, we will call it a structure. This is the tower. Supporting structure is called the tower. This entire massive structure is known as the tower. So tower of the wind turbine carries the nacelle and the rotor. Towers may be made from the steel or concrete. The range of the tower is from 12 to 37 meter for small applications and 30 to 75 for higher applications. See, more than 100 meters towers are there. And also one more advantage, if the height of the tower is increased, means the wind velocity will be more in the upper atmosphere, so we can harvest more energy. At the lower atmosphere, since buildings and trees, everything is there, so once the wind blows, there is a possibility for the resistance of the wind hitting on the buildings, trees, everything, etc. So the wind velocity will be always lesser in the lower atmosphere. So always the wind turbine has to be erected at a particular height. So above 50 meter, 100 meter height, they will be erected. So the supporting structure will be very, very massive, okay, and huge in structure. So that is very important. So any accident happens, it will be very dangerous for the human beings living in and around. So the wind turbines are not proposed in the very high populated areas. So that will be very dangerous for the people living there. Now you might have heard about, that's all about the components. Now you might sometimes you might have heard about upwind machines and downwind machines. Actually it is not a classification of the wind turbines, that's why I am not included it in the classification, but still we can say it is two types of wind turbines: upwind machines and downwind machines. Upwind machines are those machines that have rotor facing the wind. See, if the hub is coming in contact with the wind first, then we will call it a upwind machine. See, behind the hub we have the nacelle. In these machines, the wind meets the rotor first, then leaves from the direction of which the nacelle is located. So wind will be always hitting the blades first. After hitting the blade, it will be passing over the nacelle. So nacelle will be coming second in the case of upwind machines, or the wind turbines. Blades facing the wind direction is commonly known as upwind machines. In the case of downwind machines, the rotor is located downwind of the tower or behind the nacelle. Blades will be there. So the wind will be first touching the nacelle, then only it will be hitting the blades. That types of windmills are known as downwind machines. This means the nacelle comes first in the path of the wind and then comes the blades. So just either the wind is hitting the blades first or second. Based on that, we will call it as upwind machines or downwind machines. If the wind is directly hitting the blades first, then passes through the nacelle, then it is called upwind. If the wind first hits the nacelle, then is in contact with the blades, then it is called downwind. That's all about. Okay. So that's all about for today's presentation. In the next presentation, we will be discussing about the classification of the wind turbines, and we will see horizontal and vertical types wind turbines in details. Okay, and advantages, disadvantages, everything will be discussed in the next presentation.